Okay, this is the first lesson on in Unit 4, exponents and exponential functions. We're going to be talking about integer exponents today. So we are going to be we've been talking about exponents before, but we actually want to talk about negative exponents and zero exponent as well. So the goal is learning how exponents work so that we can simplify algebraic expressions. And so what we're going to do today is evaluate expressions involving integer exponents. So simplify them and then evaluate, and then simplify algebraic expressions. So the question is, how many 2's are multiplied together in each of these questions? And so you can think about it. And so we're actually counting the number of 2's in each of these, and these are all powers of 2. And so we can say there's 5 here, and 6 here, and 4 here. So in total, there's 7 2's multiplied together. Don't get me wrong, this doesn't equal 7, so it's actually going to be 2 to the 7, but there's 7 2's multiplied together. Here we can say that there's 7 2's here and another one here, and then 5 2's here. And so in the final answer, there's actually 3 2's because some cancel out. And so the question is, like, what is an exponent? And so what did we just do here? And so an exponent, what it is repeated multiplication. So 2 to the 7 is just 2 times 2 times 2 times 2 times 2 times 2 times 2. That's where we got 2 to the 7 from, because if you had 5 of them and then 6 more of them and then divided by 4 of them, there's a whole bunch of canceling out that we're going to see in this lesson. The 2 is actually what we call the base, the 7 is the exponent, and the whole thing is the power. So 2 to the 7 is called a power. This repeated multiplication is really a big part of understanding what exponents are. We're going to keep coming back to this even when we do the next lesson on fractional exponents. So a little bit of a chart here to kind of work through. And so there's some things that you can kind of see as well already. And you know what some numbers are. So 2 to the 1, we know 2 to the 2, 2 to the 3, 2 to the 4, 4 to the 1, 4 to the 2, 4 to the 3, 4 to the 4. The question is, like, what's the pattern that would make 2 to the 0? What does that mean? 2 multiplied by itself 0 times. Well, if you look at the pattern of multiplying, if this pattern continued the other way, well, we can see that there's a division here. 16 divided by 2 is 8. And so we actually get 1 for each of these numbers. 3 divided by 3 is 1. 16 divided by 4 is 4. 4 divided by 4 is 1. That gives us a pattern for negative exponents. So 1/2, 1/4, 1/8, 1/3, 1/9, 1/27, 1/4, 1/16, 1/64. And if we multiply this way, what happens is we actually divide this way. And so exponents actually tell you that you're multiplying, but negative exponents tell you that you divide by the base. So it tells you to go back the other way. And the number you always start with is to the 0, the 1. Now, this is a helpful idea because in applications, it's going to be 100%. It's what we start with. It's our starting percentage. And when we multiply by a base, we change 100%. When we have a negative exponent, so we divide by the base, we get smaller, and we always have that 1 on top. And this pattern works because we've got multiplying by the base one way, dividing by the base the other. So in general, if you ever have an exponent of 0, the power is 1. And if you ever have a negative exponent, it's the reciprocal with a positive exponent. So back to the exponent rules. So these are things that we've done before, I think in grade 9, in grade 10. But just a warning here. I don't love these exponent rules. When you live by rules, sometimes you forget why, and then mistakes are really easy to make. And so the product rule is saying that we can add the exponents, but I want you to understand the reason why. With this repeated multiplication thing, we can see 4 3's times another 6. That's why we add to get 10. We can see 7 3's divided by 3. They're canceling out, and we end up with 4. So 7 minus 3 is 4. But here's an exponent rule, so keep the base the same and multiply the exponents. Well, what about that extra 2 there? So the rule says that we can multiply the 3 by the 4, but what happens to the 2? So remember what we're doing here is multiplying 2x cubed 4 times. So what that means is the x cubed, yes, it becomes x to the 12, but the 2 multiplies by itself 4 times, and we get 2 to the 4 as well. So anything to the, so now what happened there was the 2 was actually raised to a 1 as well, and the 1 times 4 gives you 2 to the 4. But it's really a little bit easier to see if you just visualize that 2x cubed written out 4 times. You can see that there's a 16, 2 times 2 times 2 times 2, and there's x cubed 4 times. So some questions you can try on your own. I'm just going to kind of walk through them. 3 to the 5, 3 to the negative 2. There is that exponent law that we can add the exponents. Even when they're negative, we get 3 to the 3. And we can use that exponent law. 3 cubed squared is 3 times 2 is 6. And 3 cubed, if we subtract the exponents, we get 3 to the negative 3. And what that is 1 over 3 cubed, which is 1 over 27. When we do this in future examples, what I'm going to actually do is something a little different strategy with a 3 to the negative 2. But this exponent law of adding and then subtracting totally works. 2 over 3 to the negative 4. What that means is 2's to the negative 4 and 3's to the negative 4. Now what that means is like we actually have 2 fractions divided by each other. 1 over 2 to the 4 divided by 1 over 3 to the 4. I write it this way because I like to avoid the fraction over a fraction kind of thing, like 2 fractions inside another fraction. So I like to use the division sign, but it also helps me understand that like I remember how to divide fractions, and that is flip and multiply. So we end up with 3 to the 4 over 2 to the 4. I'm gonna give you a strategy for how to skip those steps because if we understand something. But for now, that's how we can solve that. And so that's 81 over 16. 4 to the negative 7 is 1 over 4 to the 7. Sorry. These weren't the same base. And so now, kind of in the same theme of counting the number of 2's, what we're actually going to do is try to count the number of 2's here. Now, 4 is a 2 squared. 2 squared is to the negative 7. 2 squared to the negative 7 is 2 to the negative 14. We can use the adding exponent law to get 2 to the negative 5 and say that's 1 over 2 to the 5. So that's 1 over 32. If you don't do that, you end up with something like 4 to the power 7, and you actually don't want to solve something like that. You can see in the next one, I don't want to actually do 16 to the power of 3. What we're going to do is we're going to use the fact that they have common bases to help simplify so that we can avoid really using a calculator, but also see the power of the exponent laws. So 8, 4, and 16 are all powers of 2. So we can say 8 is 2 to the power of 3, 4 is 2 to the power of 2, and 16 is 2 to the power of 4. So the next step really just replaces those 8, 4, and 16 with 2 to the 3, 2 to the 2, 2 to the 4. Now we're just counting the number of 2's. You can also do that if you identify the common base of 2 without showing the step. So you can ask yourself just how many 2's are in 8 squared. And so since there's 3 in 8, then there's got to be 6 in 8 squared. So this guy is 2 to the power of 6. This guy is 2 to the power of 8, and this is 2 to the power of 12. We know 6 plus 8 is 14, and then 2 to the power of 14 divided by 2 to the power of 12 is 2 to the power of 2, because all but 2 2's cancel out, and we're left with 4. A common mistake over here is saying that 3 to the negative 3 is negative 27. It's really just not understanding the pattern that we're dividing when we do negative exponents. Or you might understand that, but then you say, well, it's still got to be negative because there's a negative sign. None of these, the only way you would get a negative sign from any of these questions is if there was a negative in the question. Since there are no negative signs in any of the bases, you're not going to get negative signs. The only time you're going to get a negative is if one of the bases was negative.